Welcome back to The Invisible Industry, the podcast where we discuss and educate on everything you didn't know about agricultural rendering, brought to you by the North American Renderers Association, or NARA. As always, I'm your moderator, Anna Wilkinson. I'm the Vice President of Communications for NARA, and joining me is our host, Mr. Marcus Wintzer. Now, today is the second installment in our series, Where Do Rendered Products Go? This is an educational series where we explore where rendered products actually go, how they're used, and how they're processed in those industries. As you may recall, in episode 5, we talked about how rendered products are used in animal feed, and today we're going to be doing the same thing, but we'll be talking about the plasma industry. To help us with that is our esteemed guest, Dr. Yanbin Shen. Marcus, I'll go ahead and turn it over to you to introduce Dr. Shen to our audience.
Thank you very much, Anna, and thank you all for joining us here today. Dr. Yanbin Shen is the Global Technical Services Director and North American R&D Director at APC Inc. APC Inc. is one of 7 independent companies under the Lordson Group Inc. and is headquartered in Ankeny, Iowa. APC was founded in 1981 and is dedicated to the research and application of blood products and animal nutrition. The company has grown into a global manufacturer and supplier of porcine, bovine, plasma, and hemoglobin. Dr. Shen received his BS and MS degree from China Agricultural University with an emphasis in animal science and feed technology, and his PhD is in swine nutrition from North Carolina State University. He has authored more than 20 publications, including scientific abstracts, conference proceedings, and refereed journal articles. He also serves as adjunct professor at Department of Animal Science at NC State University. Welcome, Dr. Shen. Thank you for joining us here today to talk about plasma.
Thank you, Marcus. Thank you for hosting this episode, and thank you. It is a really great honor to have this episode with you and the NARA.
I guess we'll jump right into the questions. I'm not very familiar with plasma. I was wondering, could you define what plasma is for us and for our listeners?
Yeah, absolutely. So plasma, it is a food and feed ingredient, right? It comes from the blood. It is a high protein and highly functional protein ingredient for food and for feed. From a nutritionist standpoint of view, as I'm a nutritionist, there's essentially, I think, 2 very unique features about this product, which is the first one is it has very high protein and highly digestible, right? And that will help, if you think about the pet and pet food application from the product, it will increase their digestibility and lower their GI issues. The second point of this product is it also has functionalities. There are biologically functional proteins in the product. Because the way we process the plasma, we can maintain the functionality from those proteins, and those functional proteins can in turn act in the GI tract and also systematically within the animal by improving their health, and improving their immunities, and therefore improve productivities of farm animals. Or in the pet food side, improve their health.
Thank you for that definition. What are the different types of plasma?
So primarily, we have spray-dried plasma, both from 100% bovine or 100% porcine origin. The reason why we do a spray-dry is this kind of a pretty unique process can help us to inactivate initial pathogens in raw material, but also maintain the functionality of the proteins in the product. We do have a granular version of plasma. The reason why we have that version of plasma is because for some feed mills, they can handle a granular version of the product better than a powder version. So we have a granular version. But the granular versions also come after the spray dry process, so it doesn't impact the functionality of the product. Beyond that, we also have a slightly different skill for calf application, because in the calf milk replacer application, they would require to have a higher standard on color. So we have a NeutroPro product which has a high color standard that are geared for the calf application. So the bottom line is primarily the product is being spray dried, and we have spray dried plasma, and we have some little iterations from that based on customers' preference and the request.
Could you describe the difference between, or what is the difference between plasma and blood meal?
So plasma came from blood, right? It's a fraction of the blood. If you are, animal science major, or if you are a biology major, and you have worked on, on the blood samples, once you collect the blood sample, let's say from a rabbit or from humans, you need to process the blood, say centrifuge down. You will see the separation of the blood, right? If you have a tube of the centrifuge, you will see the red blood cell will accumulate on the bottom side of the bottle, and on the top side you will see a clear yellowish clear liquid. That part is plasma. So plasma came from blood, but we purposely separated the red blood cell from plasma because the plasma fraction has the functionality. So if you look at the plasma versus blood meal from a composition standpoint view, plasma is a fraction of the, if you will, the whole blood. That's one of the differences. The second difference is the processing. As I mentioned, the spray dry is a very delicate process that will help us to maintain the functionality of those proteins. So versus the blood meal process, blood meal is typically ring dried. And the ring dry process has higher heat and longer period of time. Typically, with the ring dry process, you're going to inactivate the functional proteins, so you're going to lose the functionalities through that process. That's the main differences between plasma and blood meal. And because of the composition differences, nutritionally, the matrix value or the nutrient profile between plasma and blood meal are also a little different. Let's say, the lysine level, the amino acid level are a little different between plasma and blood meal. And also because of the process, blood meal typically has a lower digestibility than spray-dried plasma.
I was thinking that it probably would have a lower digestibility since you're heating it a lot more. With blood meal, you're using all of the blood, and rather than just separating out the plasma and using it there.
Correct. There's actually a couple of papers just published last year from Purdue University. They looked at spray-dried plasma and the ring-dried blood meal, looking at their digestibility levels in a piglet model. They find about almost 40% differences between those two in terms of digestibility. So so there are quite significant differences between plasma and blood meal.
So can you describe the basic process on how you create plasma?
As I mentioned, the plasma came from the blood. The whole process, basically we're producing a natural product from a byproduct from the packing houses, right? So basically, at the packers, we try to collect the blood or plasma. So at the packer side, at the packing house, we typically will add anticoagulant right after collecting the blood from the lines. And then after we add anticoagulant, the whole blood will be transferred into a enclosed system, which are on site at the packing house. In that enclosed system at the packing house, what we will do is we will do a centrifuge using a commercial centrifuge to separate the red blood cells and plasma. Red blood cell, in some cases, will leave it to the packers, and they will do their rim-dried, blood meal, or they will add it to their other render product. In some other cases, we'll bring back to some of our manufacturing facility to make it into a spray-dried red blood cell or spray-dried hemoglobin. The plasma portion, what we will do is we'll pump it into a tank at the packing house. We'll chill it immediately because it is a fresh material out of animal, right? We want to chill it so that we can reduce the potential microbe growth of the product. We chill it, we store it in a tank, and we will have our dedicated tanker owned by APC transport the chilled raw liquid plasma to our manufacturing plant. At our plant, what we will do is first we will do ultrafiltration actually having the product going through that nano system. What that does is it will help to reduce the water levels in the raw plasma, and also reduce the ash levels in the raw plasma, because we added anticoagulant, so we want to take some of the ash out, but more importantly, to take the water out, because the raw material itself is 90% water. If we run that through a spray dryer, it will require a spray dryer to take out a lot of water, right? So we run through the nano. Nano will take a lot of the water and ash out. Then we'll run the spray dryer and make it into a powder form. In some of our facility, before spray drying it, we also have a UV system. That's a pretty unique system to APC. We use that UV system as a additional kill step to kill potential bacteria and viruses in a raw plasma material. So, in a nutshell, that's how we're manufacturing this product.
What sort of products do you use? Your finished product. What sort of products does that go into?
We primarily use plasma into feed or pet food applications. Those are primarily how we're using plasma today. On the food animal side or feed side, we primarily use plasma in young animal feed. That include piglet feed, cat milk replacer, chicken feed, young chicken feed, shrimps, juvenile fish feed. So primarily on the young animal side. The reason why we do that is because it's kind of a long story. About 40 years ago, when we just started the plasma business, APC is actually the business the business entity discovered this unique application of plasma in young animal feed, in young piglet feed. 40 years ago, when we run the trial with Iowa State University in piglet, they saw a huge response from the piglet in terms of improving their growth rate, intake, feed efficiency. And they went on stage, shared this news with the scientific community at that time, where at that time nobody really believed them because the response are so big. But 40 years later, piglet application in the feed are still the single biggest application we have today. Of course, we have expanded that into other species. Most notably, it's calf milk replacer. Today, in the North American market, we probably are in 70-80% into the 70 to 80% the calf milk replacers diet. So about 70 or 80% of the calf produced today in North America they are consuming plasma in one way or another, and that's on the calf side. Of course, in the last few years, we have pushed very hard on the chicken broiler application as well. The concept is the same, right? You want to build a very good foundation using the functional protein from plasma with the young animals. In this time it's chickens, right? We put them in the first diet. And we have shown and the functionality from plasma, we can improve their feed efficiency, lifetime feed efficiency, reduce mortality. So we're growing that chicken business as well. On the shrimp and juvenile fish side, the similar concept. But those on the aquaculture side, we are developing that business as we're speaking. It's not as mature as some other species like piglet, calves. Another part of application of plasma is on the pet food side. Cats really like plasma. We have a internal joke here saying that plasma to cats like cocaine is for cats. They really like the palatability from the product. So you're seeing a lot of application of plasma in the cat's diet. We're also growing the dog application as well. We're getting very exciting new research and discoveries on the dog and on dry side as we're speaking. But that's in a nutshell how we're using plasma in different products.
So in order to make plasma, it sounds like you have basically two streams: the bovine and the porcine blood. There's I guess there's no other real source for those. There's no artificial or anything else that you could do except get those from those sources. Is that correct?
That's absolutely correct. We produce all natural product, right? And this is the functional proteins and all this functionality actually came from all naturally from the animals. We do not use any other alternative ingredient. We don't try to alter the product by using substitutions and things like that. No, it's all natural product, came from the whole blood.
So could you describe what the final product looks like? Is it, it sounds like it's, like you said before, pelletized or a powder. Then do you add that then to whatever is going to be the feed for the animal that you're making it for?
So the final product after spray drying is a white beige colored powder. It's very, very consistent. It's very uniform white powder. As I mentioned earlier, we have a granular version because in some feed mill they prefer to use a granular version because it's easier to go through the pipes. We can calcinate the white powder into a granular version. And with those, with either powder or granular version, you can put it into the feed directly, right? And for example, in the piglet application, you can put 5% plasma into your ration, and they will mix it in and make a new whole complete diet. On the pet food side, if you're making let's say a canned food, you can mix plasma into your meat mixer at 2 to 4%, and you can just put it in. It's very the product is highly soluble, and if you put it into the meat mix, it will dissolve in there and actually provide a lot of functionality in terms of helping emulsifying the meat mix and helping provide the a little bit of viscosity as well. So it's a very easy to be used product.
In an effort to understand future demand, what sort of growth do you anticipate in your products over the next 3 to 5 years?
That's a great question. As I mentioned, we are we have been in the blood business, plasma business for over 40 years, right? Over the 40 years, we have really grown the business quite a bit. Compare the business versus today versus 40 years ago, we really have grown a lot. So it's a more mature business today compared to 40 years ago. But with a lot of this global trend, we do see or anticipate further growth in the next 3 to 5 years, maybe 20-30% growth. If we can hit the target. The main reason is because on the food animal side, we are seeing a lot more emphasis on reducing reliance on medications, right? We all want to have animal being produced without antibiotics. This global trend of demedication will require a better young animal nutrition or young animal health. We really played very, very well in that arena because the functional proteins, for example, the immunoglobulins and some other immune factors from the plasma product, can really help the young animal to thrive without the antibiotics. In Europe, they also removed the zinc oxide because of the concerns of antimicrobial resistance concerns. And with removal of zinc oxide, it will also help our business in longer term. On top of that, we're also seeing even on the pet side, people are requiring more natural or more sustainable product. And plasma, it's came from the rendering, came from the packing plant. It's a waste product, right? We're using a waste product, turning it into a very useful and unique product to for the industry. So it's all natural, and the sustainability side of it is also very unique and profound for the industry. So, both from the demand side on the food side and from the pet side, we're anticipating significant growth in the next 3 to 5 years.
So currently and in those next 3 to 5 years, what sort of challenges do you face and what sort of challenges do you anticipate you're going to have to face?
I think, the main challenge we're facing today, which I think we will be able to overcome over the next few years, is this animal byproduct free claim on the food label, right? If you go to the grocery store, maybe earlier this year or last year, if you go to the grocery store and try to pick up a chicken breast, you'll find maybe 60% or 70% of the chicken product will have a full label saying the chicken has never been fed with any animal byproduct before, right? That's kind of built in their label. This is actually a long story with this marketing campaign on the food side, removing animal byproduct from the chicken production. Number one, you have more recent consumer survey came out, consumer study really came out, looking at, when consumers go to grocery store, when they are buying food, chicken or beef or pork, when they look at the label, what are they looking for, right? There's recent consumer survey and study came out and basically said consumer care about antibiotic free label, right? They don't want their animal or the meat they're eating, the animal been fed with antibiotic. That makes a lot of sense. They want a natural claim, right? They want the product to be a natural, and they want to have a higher welfare standard for the animal they are buying. Those all make a lot of sense. Those are ranked the top three for their preference. The study also looked at the animal protein-free or vegetarian label as a category. It ranked the lowest among few studies came out last year, right? And also when the researcher going to ask, they asked about the consumer about this claim, animal byproduct claim, free claim, they actually misunderstood the claim, thinking this animal byproduct free claim is meaning better welfare for the animal, which are clearly not the case, right? Because we know animal byproduct typically has higher digestibility. With using animal byproduct, an animal is actually healthier and more sustainable, right? So there's a mismatch on that side. So we're really trying very hard from our side, try to convince the packers and the food producing company, this is a mistake. We need to come back to animal byproduct. We need to remove that label. I think since last year, we're seeing some poultry producers are making that change. We're seeing a significant reduction of that animal byproduct claim right now in the North American market. If we talk about it globally actually, it's trending to the other side. If you look at Europe, because Europe are trying to make more sustainable animal agricultural production, they put a lot of emphasis on circular economy and sustainability. If you look at that aspect, plasma or render product really fit very well to that overall campaign, right? You want to produce a product, but you also want to efficiently use the byproduct. I guess in a short summary, and the animal byproduct free claim was, and it's also currently some challenge we're facing today in North American market. But over the time, I think people will recognize the efficiency and the sustainability benefit that can be brought by plasma and other animal byproducts. So we'll overcome that challenge over time.
The whole world seems to be trending towards sustainability, which makes perfect sense. If we want to thrive, we got to be sustainable, so things can continue forward. So, yeah, hopefully that message gets through of being so sustainable.
Yep.
So, what sort of advantages, competitive advantages, do you feel you guys have versus your competitors with your plasma?
We have a product that works in young animals and in pets, right? And we have 40 years histories on this. Just to share with you a little bit, because I'm handling the R&D side. I recently run a study with Illinois and also North Carolina State University in piglet, right? At a similar level of plasma we used compared to 40 years ago, we saw exactly the same response, right? And so significant. So the bottom line from that is we have the product really works in young animal, and it's working very consistently, right? No matter kind of what conditions or genetic changes or environmental changes, it works. So that's our competitive advantage, one of the biggest competitive advantage. Of course, over the last 40 years, we published 600 papers on different applications, pets, piglet and calf, chickens, shrimp, you name it. And those publications or those R&D work really enabled us to know how to help our customer to use this technology. That's also our competitive advantage versus our competitors.
Really want to thank you for being here today, Dr. Shen. It was really a pleasure and to learn about something new today. Thanks again.
Thank you, Marcus. Thank you for hosting this episode. It was a pleasure to be here and talking to you about the plasma protein.
Thank you again, Dr. Shen, for educating us today. And as always, thank you, Marcus. And thank you for joining us for another episode of The Invisible Industry. We hope you'll join us again. For more information on the North American Renderers Association or rendering, you can visit us online at nara.org. Stay curious, everyone. And to all our rendering listeners out there, stay seen and stay green.